Hello everyone. Today we have alongside us Lidia Rățoi, Assistant Lecturer and Robotic Fabrication Researcher at the Honk Kong University. Hello Lidia.
Hello everyone.
Tell us a little bit about yourself.
It's quite a long story, I would say. I studied architecture, majoring in interior architecture in Romania at the Ion Mincu University in Bucharest. I liked architecture a lot, but because before that I was in art school and I studied piano, so I really felt like there's too many rules, it's too conservative, so I really was looking for something more creative to do. When I was in first year of architecture, right at the end, I started looking into parametric design and what it means, and I discovered it's basically a way of doing architecture based on code. That was how I started to develop my more experimental, more digital-oriented style of architecture and type of architecture that I wanted to look into. I also started at that time in the second year of university to work for a Romanian architecture magazine. It was called Atelierul de Proiectare. And that was a very good opportunity for me, not just because I love to write, but because I had a lot of freedom and we were quite a young team. I had the opportunity to talk to all these people that were doing this really cool type of architecture, this really cool design, 3D printing and all this. I got to meet them just because I would write to them and ask them if they agreed to be interviewed, and usually they did. That was quite a nice learning opportunity. I really didn't have the opportunity to do in school the kind of thing that I wanted. My school was a bit conservative. Now I understand it more that I'm a little bit older, but at the time I had this very rebellious attitude. I just started looking into computational design, and so I started to learn a lot of new software, like Grasshopper or processing or Arduino. I started a little bit working with machines. I did a few workshops where we did digital fabrication methodology, like laser cutting, 3D printing. The first one I did was in Bucharest. It was a collaboration between Parametric IDG Fab School and Code Italy. That was, I think, my first experience actually producing something with digital fabrication. Then I started working for H2O magazine. It's quite a big publication, and that's actually how I met you, Christina, when you were also working there. I finished my studies. I was doing a lot of stuff during school. I was quite lucky that I had this opportunity. I was working in fashion design. I was working in jewelry design, product design, stage design. And then I discovered this program at IAC Barcelona. It's called Open Thesis Fabrication. And it's basically 6 months. You are allowed to go crazy with a robot, build something really big. The year that I went, the theme was robotic printing with clay. We were required to build a house that would take advantage of the properties of clay material in order to be a house that provides environment for itself. So it's able to heat itself and cool itself naturally. We use Grasshopper mainly, but a lot of Grasshopper environmental plugins like Ladybug, Heliotrope, all these kind of plugins. I also learned a lot digitally, and it was my first experience working with a robot. I also discovered there's a lot of manual labor when you work with robots, which for me was the biggest surprise. I did my thesis in Barcelona, and then I worked a little while for Numena. Then I had to go back to Romania for a while. I did work for instance, a Romanian brand by two architects. They do 3D printed jewelry and metal casting. Then I moved to Copenhagen. Eventually I worked for KDK, which is the Royal Danish Academy of Fine Arts. The theme of the research that we did that year was adaptive facades for Nordic climate as climate givers. Usually you see this in areas of the world where it's very hot, so facades are designed with cooling systems. But this was interesting because we had to design with heating systems and do it in an environment different way, and again use a lot of digital tools and a lot of digital fabrication. To be honest, I left Copenhagen more because I really didn't like the city. And I just wanted to escape and go somewhere where it's warm and where the people are warmer. And I moved to Hong Kong. I'm an assistant lecturer here. I work in our robotic fabrication lab. So I work with robots, I work with 3D printers, I work with a lot of digital machines. And we have different tools that we put on the robots, and we work with that. But I also teach second-year architecture studio. The studio is a lot oriented on modernist architecture and then traditional architecture. So last semester, my studio focused on Japanese architect Kazuo Shinohara. And this semester, we focused on traditional Chinese houses and ways of adapting them for the 21st century.
You have recently had a post about your students' work regarding the traditional houses, combining them with modern structures. Where did the idea come from, and what's the purpose of this exercise?
It was actually grown organically. It came more from the head of the year. We all participated in it, and it grew organically from what happened in Hong Kong last year with the protests. And there was this very perceived notion that China and Hong Kong are not in the best relationship. So we said we don't care about political issues, and we want to support everybody. It was basically a peace offering through architecture. So it was very interesting for Hong Kong students who were protesting to study Chinese traditional architecture. That was basically the peace offering that we made, but also the fact that Chinese traditional houses have very particular structures that we thought is going to be really interesting for students to research on. And then the insertion with modernism came, first of all, because in the first semester they studied a modernist architect. So we wanted to kind of tie the semester somehow. We thought a lot because initially the idea of the semester was that in the final stage we actually go to China and we tear apart the house and we rebuild it, and they actually see how the structures are done. But with the limitation right now, with the coronavirus and everything, we couldn't go to China and we couldn't allow the students on campus. So we thought we will take this into consideration. So we gave them the mission to do architectural models by using some traditional architecture materials like foam or wood or paper, but the rest of them using ready-made objects that they can find in their houses. This was to take into considerations the ones that were quarantined or the ones that were not in Hong Kong. But we had to change a lot throughout the semester. It was basically always a loop between us and the students.
How did it work now?
Actually, in Hong Kong, I think for us it wasn't that difficult because we already had online teaching last semester. They didn't allow students on campus after the protests got a bit violent. The last month of the previous semester, we already were teaching online. Then we had them return on campus for a few weeks, and then the whole corona situation happened. For a few months, they were completely banned out of campus. Now some of them are allowed on campus if they need to use machines. They have the possibility to use the HKU facilities right now, but the whole teaching was done online.
Do you have a favorite project that you have worked on during your discovery of robotic?
I think the current research project we have in the robotic fabrication laboratory is my favorite because it makes me feel good about myself as a human being. It's a collaboration between the architecture department and the marine biology department in Honk Kong University. It was started by Christian Lange. I joined the team, and we also had for a while our assistant, Dominic Ho, but he had to leave Hong Kong because of Corona, because he's from the Philippines. This collaboration is about robotically printing tiles that act as microhabitats for corals to grow on. We are basically building homes for corals. Hong Kong lost 80% of its corals 2 years ago when there was the Mangkhut typhoon, which was the strongest typhoon in the last 100 years. Basically, the marine biology department was looking for a way to solve the issue with the corals. So we designed these tiles that act as a microhabitat, and they are site-specific. They can work only in Hong Kong because they are developed and the geometry is developed taking into consideration all the Hong Kong particularities and the Hong Kong waters, which are one of the most polluted in the world, and the subtropical climate. I think this project is my favorite because sometimes I think architecture has a little bit of evil quality in the sense that we take space from the world, and I wonder sometimes, do we really need another museum, or do we really need another mall? When I got to do something like this, I felt a little bit better about my contribution to this planet and to this world. It's very gratifying. For example, now we are already deploying some tiles underwater, and we did tests to see if the corals are growing out of tiles, and we got positive results so far. The corals are reacting well to the clay tiles because clay is a natural material. We're not damaging the water in any way. So it's very gratifying to see the little corals grow and starting to become something.
How do you measure the growth? How does this work?
The research process, it was a loop system between the architects in the team. We knew what is doable in terms of 3D printing, in terms of material. And then we had to learn a lot from the marine biology department. I had no idea about corals and how they grow. How we design these corals are basically, they are microhabitats, and they have these special pockets in which we place the corals. And they are forced to grow just a little bit horizontally, because corals tend to grow horizontally. But the geometry, the way that it's made, it forces them to grow a lot vertically. And this is because in the Hong Kong waters, there's a lot of algae and other species that grow a lot faster than the corals, and they suffocate them. That's why we really needed to design something that would push corals to grow as much vertically as possible and as fast as possible, because they grow quite slow. Even though it's a subtropical climate, there's still cold season and hot season. They only grow in the hot season. That's how the geometry came to life. And the way that we're measuring it, initially we just had some tile parts that we put in the tanks in the marine biology department, just to see how the corals react to it. The only thing you can really measure right now, because they grow very slow, so you can't really observe a lot of growth. We just started this month, but you can see if the material was not working, then the corals would die. Given the fact that they are still alive and they are growing, it's a good sign. And the tanks, we didn't have the really proper simulated environment, because there was quite a bit of algae, but no fish that eat the algae. But we expect in the real underwater, it's going to go even better. As an architect, you wouldn't normally see or have any connections to these things. So that's why I think this is my favorite project.
What are your plans for the future?
We might have another collaboration with the marine biology department. And I personally am really interested in 3D printing and doing it that in a way that is environmentally aware. I'm doing right now a lot of research into alternative materials like bioplastic and plastic made from natural composites. So I'm at the stage where I'm just testing different materials with different geometries and seeing how they work, and testing different recipes of materials and all these kind of things. That research is quite in an incipient stage, but that's what I'm mostly interested in, how we can use machines in a way that we don't participate even more to damaging this poor planet that we kind of destroyed being selfish. Machines can be something evil if you are not using them properly, but they can also be something that could actually help us get out of the situation that we're in.
What is the most unexpected technology that you wouldn't have ever thought that would be fit into the world of architecture, that you are now using and you can't imagine your life or your career without?
Before I went to Barcelona, I really didn't imagine how you can use robots in architecture. Speaking of working with students and technology, what I really like when we work with robots, especially when we work with 3D printing, is that material always has its own behavior. So concrete behaves in a way, clay behaves in a way, plastic behaves in a way. And it's not that easy to account for it. So there's a lot of space for discovery and for mistakes that lead to something cool. So I like a lot working with students in the robot lab, because I always discover things, but they also discover things from what I teach them or what they are taught. So it's always a continuous process, and I always look at it and I'm like, oh, I didn't know you can get that, or I didn't know you could do that. So it's always a surprise, and the more inputs you have and the more students you have, the more you are going to discover things. If I were to choose something that is really surprising for me, it's how much with the same machine and the same material you can gain unlimited possibilities.
If you would have a saying into how architecture is being taught, what changes would you make to the school?
Generally, I would make a change in Romanian schools. I think we are incredibly harsh on students. A lot of time I was in situations, not only in university where I was already a little bit older so I could handle it better, but in middle school and high school where teachers were just really, really harsh. And now that I'm a teacher myself, I really don't understand these kind of reactions, why you cannot emphasize with these are kids. They don't know better. One thing that I would definitely change is I would make a national appeal for teachers to be a lot more lenient with their students. I also think Romanian school, in a way, it's good because we work really hard in Romania. Like I've taught in Copenhagen and I've taught in Hong Kong U, and I can really say that the most hardworking was in Romania. Hong Kong students and Chinese students are still quite hardworking and they do work a lot. But Romania, I think, was just assassinating the students with the volume of work and a lot of topics. I don't think they were really relevant. There are things that I've never gotten to use. I would definitely refresh a little bit the methodologies. The biggest frustration I've always had as a student, and now that I'm older and I teach myself, I really think in Romania we have a problem with the way in which we treat students. They are not really treated as, they're not even treated as human beings. They are treated as creatures that have to produce, and have to make the teacher look good, and they don't really have a lot of freedom. So also freedom of expression and freedom of researching and freedom generally, I think, is something that we need in Romania for the students. I do agree that by working us so hard, Romanians tend to do quite well in architecture studios or wherever they go to work in the world, because we have this incredible work ethic, and we're used to deadlines. We don't complain that we have to work all night or we have to do 14 hours work days. But I'm not sure that's to our advantage. I write for Cloth magazine as well, and I did an interview with one of my favorite architects, Lidia Rățoi. He was actually an invited professor in Honk Kong this semester, and I like that he said that the architect should be a generalist. And I really do think that as well, that the more books you read, the more movies you see, the more you travel, the more you have experiences, the more you talk to people, that will contribute to you being a better architect. So you should have the possibility of having some sort of life outside of school where you also become the person that you are meant to become, and that will make you the architect that you are meant to become.
In what way do you think architecture can be used as a learning tool?
Well, I think involuntarily we are doing that a bit, because the cities that we grow up in shape us. But I think that can be, depends on the city that you're from, can be good or bad for you. If there was more education regarding what architecture is and how it should work, people would also know what to expect from architecture, because there are these famous buildings, for example, the Pompidou Center, and everybody either hates it or loves it, or they think it's really cool, but not a lot of people who are not architects understand the whole manifesto behind it. Architecture should prioritize a bit in all schools, not just art schools, and people should just be more aware of architectural history and aesthetics and these kind of elements, just so that they know what to expect from architecture and they know what to demand from it.
What would you recommend to someone that is passionate about robotics and 3D printing, but doesn't know yet how to choose a career path?
This was actually also part of my process, because I wasn't really sure what I can do with this once I graduate. What I would first recommend is that you have to be aware that it is not the same thing as working in an architecture studio. So you really have to be passionate about research, and you really have to be passionate about machines, and you have to be willing to sit in a dirty laboratory instead of sitting in a nice office and working. So it is still, all labs that I've worked in have this quality of being more like a factory than like an office. So this is a reality that you have to accept if you choose this career path. If you're not sure where it can lead you, what advice I can have is make sure that you are very, very good at it, and then the opportunities will come. And the more you know how to master a machine and master a software, the more ideas you will get. It's basically like in architecture school when you learn in the beginning how to draw. So the better drawer you are, then the nicer projects you're going to have, because you'll be able to do them. It's the same thing with machines. The more you learn about them, and the more you learn about the materials that you're working with, the more ideas you're going to have, and the more you're going to have the possibility to branch out and do different things with these machines. It's all a matter of being really passionate and really focused, and then you will create your own opportunities. And also, don't forget about your own personality. For example, for me, the first workshop I ever did with robots after I graduated was something that I was really, really passionate at the time. I was obsessed with Dada art, found a way of combining that with robotics. I did a project with Design Morphine. They are an international association of computational designers that I'm a part of, and they mostly do workshops and lectures. We did this project in Paris. We used the robots to paint Dada-inspired art, and we used data logic and implemented to the robot. I think it's very important that you don't get limited about the machines, and that you keep your own personality and see how you can mix that, and how you can mix what you want and what you like with the machines that you're using.
How do you see architecture evolving in the next years?
I think architecture has to be always very aware of its times. We are not really right now in a position where we can still say, oh, let's see who can build the tallest skyscraper or the biggest mall. We have to focus on something else. Ideally, of us becoming more aware of what we've done, becoming a bit at the stage where we are healing architecture, we are healing our cities, we are healing our society. And we use machines are a very good way of doing this because always manpower is a problem. The interesting things with machine is that we can use new materials that we haven't used before. One thing that I really advocate for is the use of bioplastics and recycled materials. So the machine gives us the possibility to work with new materials. And I think even more than ever, we are less concerned on issues such as style, such as scale, but we should be focused on repairing the damage that we ourselves have created. So I see the future of architecture at this point, ideally, as a more salvaging what we've done. And our mission should be to use architecture in a more intelligent way and to give up a little bit the very famous architecture ego, because architecture is not about the architect anymore. Nobody cares about the architect. Nobody should care about the architect. We should think on a more less egoistic way and a more holistic way. And I hope that's where we're going.
Thank you so much for this interview.
Thank you for having me.